Good morning, all, and a very happy new year to all. Um, I hope you have literally enjoyed 2020 by not coming to college. Yeah, being in online mode always. Anyways, we will hope for the best for the coming year 2021, and definitely we will have a lot of learning, have an enthusiastic learning in your life. Okay, that is the only thing that I can give you as a wish for the new year. Have a lot of learning in your life. Okay, and definitely you must have a healthy life and socially beneficial things you have to do. Okay, so as a teacher I will tell you, you are the new generation for the new India, and hope that you will be achieving the best that you have thought about. Okay, so with this new learning resolution, we will be beginning with the next topic of the discussion, um, that is binary trees. Okay, I think in the previous class we have talked about what is a binary tree, and why or when we call it as a binary tree, and different varieties of binary trees we have discussed. Okay, now I'll be going ahead with a simple insert operation in a binary tree, normal binary tree. In the last class, I ended my class with binary search tree, okay, that I will be taking up in tomorrow's class. So, shall we go ahead? Again, Happy New Year to the people who have joined late. Okay, we will go ahead. Yeah, probably I had stopped at this point. Okay, and now I'll be going through this. Whether the slide is visible to you, font is okay, font is okay for you? Please let me
Yes,
know from your end.
yes, ma'am.
Okay. So you can just see I have represented, or I have taken a simple array representation, and you need to construct the relevant binary tree for this. What is a binary tree? That you should keep in mind first of all. Binary tree is a tree which has every node in such a manner that every node has either 0, 1 or 2 children at max. Okay, with that background we will be beginning with this. So all of you please start trying this example on your side. Okay, have a paper and pen, please start doing this. First element, whatever that is appearing, is taken as a root. Okay, first element is taken as a root. So if I start drawing the tree, my root node will be D. Okay, root node will be D. Then start filling the elements from second element till the last, from left to right. Okay, you are starting from the first ever element that is listed in the array representation. Whatever is the first ever element, that you make it as the root node. Okay, second point tells start filling the elements from the second element till the last element from left to right until that level gets filled with the maximum number of elements that are required. Okay, can you quickly tell me what is the total number of elements, maximum number of elements at level 1? At level 1, 2 it is, 2 to the power. Okay, 2 to the power L indicates the maximum number of elements that can be associated, or that can be accommodated in a binary tree. So if I tell level is equal to 0, 2 to the power 0, if level is equal to 1, it is 2 to the power 1. Okay, so now at max I can have 2 elements at level 1. This is 0th level. Fine. Now, next element to be inserted is A. Since A has come soon after the root node, I'll be taking it as the left node. Okay, A becomes the left node. Then F. You are going for left to right. Okay, F becomes the right node of D. This becomes level 1 and it has reached the maximum limit. Now at level 2, how many elements can be inserted? At level 2, quick. Yes, it is 4. So how I can insert? I have to insert it from left to right. Okay. This is manual insertion I'm telling. When I'm trying to have an insertion operation done for the binary tree, I will be taking some other way of doing it. Okay. So now E is the node that is to be inserted. So where E comes to the left of A. Okay. E comes to the left of A. Then B to the right of A, then R to the left of F, then T to the right of F. Okay, so all these are over, and I have reached the maximum limit of level 2. I've reached the maximum limit of level 2. I cannot accommodate any more elements in level 2. So next, G. Where it has to come? Can anybody quickly tell me? Where G has to come? G has to be on the left side of E. Okay, G has to be on the left side of E. So I'll write G here. Then Q has to be the right child of E. Then there is a null. It means what? B doesn't have any children. B doesn't have any children. Left of B is null, right of B is null. So next comes V. V becomes the left of R, and right of R is null. Then J and L will become left and right nodes of capital T respectively. Okay, this is how, if a given array is like this and you are asked to generate the equivalent binary tree, this is how you are mapping that. Okay, with the simple two steps. First ever element will become the root node. Then from the second element onwards till the last element, start filling the elements from left to right, in the way that every level must correspond to the maximum number of elements that it can accommodate. Okay, in this manner you are proceeding ahead. So let me show you the final binary tree that I am getting. Are you all okay with this, or any doubt you have? Please let me know. Do you have any doubts? Say yes or no, please, quickly.
Ma'am,
Yes?
why B is not having any child, ma'am?
Why B is not having any child? Because the array given is, you can just see, your array given is like that. You can just see there are two nulls. Two nulls indicate B's left child is null, B's right child is also null. When I start accommodating from left to right. Okay, I'll also tell you one more thing. Let me just write the indices. Please, all of you write down the indices on the piece of paper that you have. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11, 12, 13, 14. Without drawing the binary tree, okay, without drawing the binary tree, can you guess who will be the children of the element with which I am referring right now? You can definitely tell. Okay, you can definitely tell. How? There is a simple axiom which is available in binary tree. Axioms you have come across. Okay, there is a simple algorithm or an axiom which tells, if L is the level, okay, if I is the index of the root node, if I is the index of the node, the left child of that particular node is available at 2i plus 1. The right child of that particular node is available at 2i plus 2. I'll repeat again. If I is the index of the node in the array representation of a binary tree, that node's left node is at 2i plus 1, index 2i plus 1, and that node's right child is at index 2i plus 2. If I apply the same thing, see, you have already drawn it by going from one element to another element, from left to right, 0 to 14th position, all the nodes I have come across. Every node I have taken and followed followed the directions of this, and according to that I have drawn the diagram. Now if I start applying the formula, I, if it is the index of the node, 2i plus 1 will be the left child, 2i plus 2 will be the right child. If I apply this and let me check. Let me check with the root node. Okay, what is the index of D? Index of D is 0. Now 2i plus 1, 2 into 0 is 0 plus 1 is 1. That becomes the left child. 2i plus 2, 2 into 0 plus 2, that becomes the right child. Okay, now if I take F as the node, if I take F as the node, who will be its left and right child? Okay, can anybody guess? Can anybody guess? I'll just I I just want you to guess this. Don't see the diagram, please. Okay. Can you have the guessing for the left and the right child? Left child indicates 2i plus 1. Right child indicates 2i plus 2. Okay. So what is the index of F? 2. 2 into 2 is 4 plus 1 is 5. So fifth index node, that becomes the left child of F. 2i plus 2, 2 into 2 plus 2, that is 6. Sixth position is occupied by T. T becomes the right child of F. This is how, without drawing the diagram, you can guess who will be the left child and the right child. Now if I take up B, okay, what is the index of B? Index of B is 4. 2 into 4 is 8 plus 1 is 9. So ninth position, null is there. What is the meaning of this? There is no left child for B. Now for right child, 2 into 4 is 8 plus 2 is 10. Okay, at 10 null is there. It means what? There is no right child for B. Left and right both are null for the element B. It means B itself is the leaf node. It doesn't have any children. Are you all getting this or no? Please let me know from your end quickly. You're getting? Okay. Now, according to this, you can just have a mapping of all the things. So this can be a very good 1 mark question, or in the interviews they may ask you, can you guess the children of this particular node? Okay, they may give you around 50 elements in the array representation, and you need to find which is the left child and the right child of the node which is given to you in a span of just 1 minute. You just have to apply that formula 2i plus 1, 2i plus 2. Okay, shall we proceed ahead? So with this background, this is one way of construction of a binary tree where array is given very clearly and the nodes are inserted from the left to right. This is one way of doing. But always this may not be true. This may not be true. Whenever a binary tree is getting constructed, the way may go like this. The user may tell that, okay, I want to put my new element in the direction that I want. In the direction that I want. Suppose that this is the existing tree now. Now in this tree, I just want to tell that I want to insert a new element to the left of B, and I want to name it as Z. Okay. So this kind of flexibility has to be given for a user. The user may decide upon what is the direction in which you want to insert the new element. Okay, this is second way of implementing binary tree insertion. This is what I will be discussing now. Please pay attention, all of you. Now, whenever you are inserting the new element, first of all, you are checking whether the new element that you are inserting is the first ever element of the tree that you are getting constructed. Okay. Whenever you're inserting, how do you know? See, now onwards, the first ever node of the tree, I will call it as root. I'll point it as root. Okay. Before I continue, please pardon me. I will just unlock the meeting. I'll just unlock the meeting. Okay, we will begin now. Now, you just assume that, okay, you just assume that now I am doing the construction of a binary tree using the direction factor. Okay, guys, you just assume that the first ever node that is available in the binary tree, I call it with the pointer called as root. Okay, I call it is the pointer root. So root is a pointer which is pointing to the first ever node of the tree. Now, you just imagine if root is null, then I would tell that the node to be inserted will become the first ever node of the tree, and that will be called henceforth as the root node of the tree that is getting constructed. Okay, what may be the base condition for the construction of a binary tree? Can anybody comment? What may be the base condition for the construction of a binary tree? If I'm inserting the first ever node, what will be the condition? I know. What is I? Praveen, what is I? To traverse the element. Okay, whenever Varsha you have written root equal to 0, can you write 0 to a pointer? Root is what? It's a pointer. Okay, it's a pointer. Can you write root equal to 0? No. Yes, it is null. So, in linked list, we have talked about if first is equal to null, that indicates what? List is empty. Similarly, if the tree that you're talking about is empty, then root will be null, because root is a pointer which is pointing to what? Which is pointing to the first ever node of the tree. First ever node, it means level 0 always. So root is a pointer which is pointing to the node at level 0. Who is available at level 0? It is the root node. This, if root is equal to null, it becomes the base condition. If root is null, then the node that I have created, that node will be taken as the root node for the next iteration. So it goes like this. I will represent the node of a tree like this only, similar to doubly list, no variation at all. Whatever is the element, that I call it as info part, and then this I call it as left child, and this I call it as right. I think I have discussed it in the previous class. So whenever I create a node, I use the same create node function. No change at all. I use the same create node function. Whenever I call the create node function, it will create me this kind of node which has info part and left part and then the right part. Okay. Now this info part, if it is filled with an element that is getting inserted, right now it is D, capital D. Okay. So if it is the first ever element that is getting inserted, then the condition goes like this: if root is equal to null. Now I will just show you the kind of the program that I will require. You can just see. Please pay attention for this. Okay, 1 minute. Yeah, why this ctype.h I have used, I'll let you know later. Now what I have done, similar to struct node that I used to create in a linked list, I have created a structure by name tree. I've created a structure by name tree, struct tree, and I have created int info, then struct tree star left, struct tree star right. So how does it look like? A node of a tree will look like left, info and right. Similar to that, the node getting created here. No change at all. Then I have type defined similar to the linked list. I have type defined struct tree star node. So any pointer of type tree will be called as capital NODE. This is aliasing. I think I have covered it many times. Next, what I will do is I will try to write a function for create node similar to the previous thing that I have done. Okay, using the malloc function, I have created the pointer, and that pointer I am checking against null. If not null, then I'll be returning the pointer. Simple create node function. Any doubt at this point, please let me know from your end so that I can proceed ahead. Any doubt at this point? No doubts. Now, I have told you that I'll be going ahead with the insertion operation based on user's input. User will tell me, I want to insert capital Z to the left of B. How can I give to the left of B? I'll give something like this. Okay. What is the new element that I want to insert? Say element I'll give as capital Z. Okay, and direction I'll give like this. Direction is equal to, I may give like this, left, right, left. So direction is what? It is nothing but a string that is taking more than one direction factor. So if I give LRL, what is the meaning of this LRL? If I take up LRL, it goes like this. Starting from the root, it will start from the root, goes to the left of root, then second direction factor is right, right of the node, then to the left of B I have to go. This is how the direction factor matters during the insertion of a new node in a binary tree. This is second way of construction of the tree. Okay, for this I am showing you the implementation. I'm showing you the implementation. Now you just suppose that I have given only L and R. I have given only L and R. It means what? Left of D and right of A. Can you insert a new node there? You cannot. Definitely you cannot, because already B is the right node of A. You cannot replace the node that is existing. You cannot replace that. So this is how I'm constructing a simple binary tree using the direction factor. So what all things required? I require the element to be inserted, and I require the direction factor, which is a string. And the direction is given from the root node till the end. If the direction is invalid, definitely the node to be inserted will never be inserted. It has to throw an error. If it is proper, only then the new node gets created, and that new node created will be inserted at a proper direction. Are you all okay with this? So that I can proceed ahead in the explanation. Please let me know from your end. Are you all okay with this? Direction, I have to explain it again. Okay. Say let's suppose I just want to insert Z. Okay. And let me give the direction as something like this. Okay. Can anybody quickly comment where Z will be inserted? Only two comments. Okay, right of R. So let's go ahead how it works. Okay. When I tell something like this, you just have to map it to the program. Okay. Please note all of you. What is there right now? At this point, root is available. Similar to linked list, what I will do, I will take previous as one extra pointer and current as one more extra pointer. Current is pointing to the root, previous is What it can be? Can anybody guess? What it can be? Previous has to follow current. Yes, it is null. You're right. Very good. Okay. Now previous is null, current is pointing to root. What happens next? Every time the direction counter will be taken. So I will take an iterator I for navigating through this direction string. Okay. I will begin from 0. What is there in this is 0th position, this is first position, and this is second position of the direction array. In the direction array, I is the index. Okay. Now, at I is equal to 0, what is the direction factor that is given? Right. What is the direction factor that is given? Right. So if direction of I is equal to right, that is R, capital R, what I need to do? I cannot move this route. Please note it. You cannot move this route. Instead, whom you are moving? You are moving the current. Current has to move to the right of right now where current is available. So how you can write? Current is equal to current arrow right. So current from here will come to the next node. But before doing that, what you need to write? You are supposed to write previous is equal to current. What you are supposed to write? You are supposed to write previous is equal to current and move current to current arrow right. Okay. Now at this point, previous is here, root remains as it is, current has come here. I will increment I. Where is I now? I is at 1. I is at 1. And direction of I is L. Okay. So, direction of I, is it equal to L? Yes, it is. It is equal to L. So, what happens? Previous is equal to current. Previous comes from this node to this node. And then current is equal to current arrow right, current arrow left. So, current will come to here. Current will come to here. Now at this point, being at this point, I just have to navigate to the next direction factor. I will become 2. I is 2. Okay. Right now I is 2. 2 indicates direction of I is R. Okay. So previous will come to current and current will move from here to here. Is it a valid thing? First of all, it is not a valid thing. Okay, it's not a valid thing. So current has come here and previous is here. At this point, what is the value of current or where current is pointing? Please let me know. Where current is pointing? Current is pointing to null. Okay, and I has reached the dead end of the direction. I has reached the dead end of the direction. Now the loop has ended. After coming out, where is current right now? Current is null, but previous is at R. Previous is at R. Okay. So, what is the value that is available at the second position? Capital R. It is available at position at I is equal to 2. The direction that is available is capital R. Okay. At 2, second position, R is available, but current has gone beyond the limit of tree. Can it insert a node at this point? Definitely. Why? Though current has moved out of the direction, out of the whole of the tree, who is holding on? The previous is still holding on. Suppose that I have given one more L. You just imagine, I have given one more L. So where previous has to be, where current has to be, previous will become null. Current will go to the left of current. What is current? Current will be null again. Previous and current both are pointing to null. Then I would tell this is an invalid direction that you have given. But right now, though current has reached null and even then previous is holding back. So at the right of R, I will definitely insert Z. I will definitely insert Z. So this is how the insertion goes on based on the direction. If you want me to explain it again, I'll explain it with another example. Please let me know from your end. Please let me know from your end. You want me to explain one more example? Then I'll do that. Only then I can go to the program. Should I explain it or is it okay?
Excuse me, ma'am.
Yeah.
Ma'am, so the
Yes.
insertion is so, so the insertion is as per the direction given by the user, ma'am.
Yes.
Not as like wherever we find a vacant space, it will insert the element.
No, no, no. This is the second way I'm telling. Second way. First way is you go on inserting from left to right. Don't look at the has it reached the highest level? You just have to check that. Okay. If anything is null, there you can fill. That is one way of doing. This is one more way.
Yes, ma'am.
Okay. Now I'll quickly explain this example and then we will go ahead. Okay. So what I will do next? I'll take a root. This is also current and previous is null. Okay. Now the direction factor given is RLLR. So can anybody quickly tell me where Z will be inserted? Right of V. And is it valid? Is it a valid direction that is given? Now if I give like this, where Z will be inserted? Is it valid? No, it is not valid. Whereas the previous one which is given, that is valid. Okay, let me just go through that. Have a look at it. Jaldi, okay, in another 1 minute I'll explain this. So this is the root as well current pointing here where previous is to the null. Then direction of 0 is R. Okay, so previous comes here and current moves to the right. Current equal to current arrow on right. At this point, direction of 1 is L. Left of F. Current has to go to left of F. So previous comes here. Current is equal to current arrow left. Next, direction of 2 is left again. Previous comes here. Current is equal to current arrow left. Okay. Then direction of 3 is R. So previous comes here. Current is equal to current arrow right. Okay, current comes here. Whether it is right or left, current will become null. At the end of the direction factor, current will become null. Now, at this point, previous is pointing at V. Imagine that temporary node is the node which is created and it is having Z as the value. Left and right both are null. It is independent node that has been created. Once the loop has ended, after the loop, previous will be pointing to the node with which the new node is getting attached. Current would have gone out. I'm just least bothered about current. Current is used only to navigate, nothing else other than that. Okay. Now Z has to be inserted. At this point, Z has to be inserted to the which direction? To the right direction. How do you know that it has to be inserted at right direction? It is available at the last direction factor that is given. So it is, I can tell at the end of the loop, I will be 0, 1, 2, 3, 4. I will be 4. So the last direction factor will be taken as the position at which the new node has to be inserted. And what is the last direction factor? Capital R. How would I get it? I minus 1. So direction of I minus 1 will give me the position of the new node at the end of the loop. Okay, at the end of the loop. So direction of 3 will give me where to insert the new node to the previous. So previous arrow right is equal to temp. This is how the new node gets inserted. Any doubt at this point? So that if you don't have any doubts, I can definitely go ahead with the program. Shall we go to the program? Please let me know. Yes or no? Okay, only one yes. All of you are awake? All of you are awake? Okay, thank you now. Yeah. Now, today I'll be giving you one assignment once I complete this. Yeah. Yes, let's go ahead. How do I insert? According to this only I'll be moving ahead. The element to be inserted, here I have taken integer, that's why I have given int element. If you want to take character, give it as char element. And definitely the info part of the structure tree also has to be changed to character if you are doing character insertion. Now, I have taken node temp. Temp is the new node to be inserted. Current, which is pointing to the root. Previous is equal to null. Okay. I hope this is clear with the explanation that I have done right till now. And I is a iterator to iterate through the direction string. Okay. Now, I have created a new node, added the element, left and right I have made it as null. Similar to the linked list that you have done. This needs no more explanation according to me. Now, the base case, as discussed previously, if root is null, return temp. Temporary node will itself become the new node. Then, otherwise, if not, take the direction to insert. Read the string. Okay. Then I will convert that to the uppercase. For this reason, I have taken ctype.h. To upper does what? Converts any lowercase into the uppercase of the array. Okay. The elements that are given will be converted into uppercase letters. Then I have started from previous is equal to null, current is equal to root. This is what I was speaking about. The loop starting from 0th position of the direction string till the length of the direction. I will take one by one the direction factor and then go ahead. Either you are breaking the loop when current is null or you are going ahead until the current becomes null. Okay, you have seen that when current becomes null, I have to come out of the loop. Okay, then this navigation, whether direction of I is L, then current you are moving to left, otherwise current you are moving to right. Make previous to point to current always. Then after the loop has ended, current would have reached the null or current would not have reached null, but the direction factor has ended. It has ended. I have given you an example in this. Okay. See, let's suppose I have given the direction factor like this. Let me insert one more. Okay, you can just see. I just want to insert, say, L. L is already there. W. I want to insert W and I'll give the direction factor like this. R and L. Please let me know from your end whether current will be null in this case at any point in time. Just navigate through the things and let me know from your end. Where current will be pointing? Where current will be, where previous will be after the end of the loop. You can just see D से शुरू होता है, right? It will come to F and left it will come to R. So current will be pointing to R and previous will be pointing to F. At this point, can you insert a W at the position of R? You cannot. You cannot. This is what is happening in this condition checking. Okay, current is not null. Current is not null. Can you insert? You cannot. Current has to be null. At this point also there will be insertion not possible. So what you are doing? You cannot insert that element. Free that element and just return the root. The second condition, I not equal to string length of direction. It means what? Let's suppose I have given the direction factor as left, right, left, right. Now tell me, left, right, left, right. At what point current will become null? You just imagine like this. Left, the first L will be taken. First L will be taken. Current will come to A. Okay. Then R will be taken. Current will come to B. Okay. Then again L will be taken. At this point, current has reached null. At this point, current has reached null. So if current is equal to null, it would have broken out of the loop. Whether I has reached the string length, has it completed the direction factor? No. At this point also, you cannot insert the node. The direction factor that is given is not correct. That is the meaning of that. So the first condition is for the sake that you have reached the dead end of the direction, but current is nowhere available at the null at the end. It has never reached the leaf node. So unless it is a leaf node, you cannot insert any node, any new node. The second condition holds the direction factor itself is lengthier than the available amount of levels. That is the condition for this, the failure condition for this second part. Okay, I have given you two examples for both of these. You can just check it out. In any of the cases, insertion is not possible. Otherwise, if this is not the case, if it has taken care all the things and it has ended the loop properly, at the end of the loop current is pointing at null and the direction factor is proper, previous is pointing to the previous node, that is the leaf node, then you are supposed to insert either to the left or to the right of the previous. How do you know? If the direction of I minus 1, don't take it as I. Why it is I minus 1? Can anybody comment on this, please? When the I loop would have ended, when I has become 1 more than the actual string length. When I has become 1 more than the actual string length. Okay, that's why you have to take minus 1 for that. By the end of the loop, you would have reached, I think I have told in this example, 0, 1, 2 and 3 are the last R that is available at index 3. But I loop would have ended when I has become 4. So now, how can you make sure that you are inserting to the previous node's right? Where it is available? It is available at index I minus 1, that is 3, 4 minus 1. So once the loop has ended, I would be pointing to 1 more than the direction factor. You have to get back to the last direction factor. How you are doing? By doing I minus 1. That's why it is direction of I minus 1. Whether it is given as L, if L, insert the temporary node to the left of previous. Otherwise, insert the temporary node at the right of the previous. It's as simple as that. Any doubt at this point? Please let me know from your end. I'll navigate through the whole function again. So this is just the declaration. I've created a new node at line number 37. Assigned the info part with the element to be inserted. Assigned left and right with the null. Then the base condition. If no nodes are there, then return the temporary node as the root node for the next iteration. Otherwise, give the direction, take the direction from the user into what direction you want to go so that the new node has to be inserted. Then I'm converting that direction factor into uppercase because the user may enter in left and right, the lowercase or uppercase mixture of that. I should not have more number of comparisons. In order to decrease the number of comparisons, I have done this. Okay. Then I have assigned previous to null, current to root. This loop is for the navigation of current and previous. in such a manner that previous reaches the leaf node, current reaches null at the end of this loop. If in between only I have not reached the dead end of the direction factor and still the direction factor is there, but even then the current has reached null, it means what? I have given the wrong direction factor. That is an error. I cannot insert. Or I have reached the dead end. I have reached the dead end, but the current has not reached null yet. It is in between. Current is still in between. Even in that case also I cannot insert the new element. So in both the cases, I will not insert the new element. Otherwise, what I will do is I will go on in such a manner. This is similar to the linked list that we have taken. There we used to do previous is equal to current is equal to current arrow, right? Because it was unidirectional, linear. Here I have to speak about hierarchical way. You want to go in the left right side or you want to go in the right side. So before incrementing current, I have to check for the direction into which the current has to move. If the direction factor is given is left, then current has to go to the left side. Otherwise, current has to go to the right side. Wherever current is there, previous will simply follow it. Okay. If at the end of the loop, previous is at a leaf node and current has reached null, it means that all the things are properly there. At that point, you want to insert the new node. The new node has to be inserted according to the last direction factor that is given. And where is the last direction factor? It is available at I minus 1 because at the end of the for loop, I would be pointing to 1 more than the actual length of the direction. So I minus 1 if it is L, then place temporary node to the left of previous or otherwise place the temporary node to the right of the previous. So the new node that you are inserting always will be the leaf node. Yes, I think I have explained it to. Yes, Praveen has a question. In line 62 for second condition, can't we check whether previous is equal to null? No, previous cannot be null. Previous always will be pointing to the leaf node if the direction factor is given properly. Previous will never be null. You have seen so many examples I have explained till now. Never previous will become null.
Ma'am,
Yes.
if I
If
not
previous has
if
become null, Praveen, before you continue, if previous has become null, it means that the place at which you are trying to insert that is not proper.
I thought, ma'am, instead of I not becoming the string length, ma'am, that is
Hmm?
the leaf node.
Hmm?
Uh, if the previous is also null, ma'am, so
Hmm?
in that condition we can't also not insert.
See, you
So
cannot insert, no, if previous is null, you cannot insert. Do you
if
insert nulls left, nulls right? You cannot. So previous has to point to a leaf node. ठीक है?
yes, yes, ma'am,
Okay.
yes, ma'am.
Okay. Yeah, any other doubts? This is a crucial part of understanding this. Please understand it thoroughly and let me know have you understood it correctly or any doubts you have. Okay, quickly, I'll give you an exercise. Within 2 minutes, you have to tell me the answer for that. Jaldi. Okay, take down. For the following set of elements, for the following set of elements, draw draw an equivalent binary tree. Draw an equivalent binary tree. And and tell tell for the followed insertion for the followed insertion validity. Okay, quickly take the elements A, B, C, D, null, E, F, G, H. I'll repeat again. A, B, C, D, null, E, F, G, H. Can you quickly draw a binary tree for this? And you have to tell me which node will not have children other than the leaf nodes. In the internal nodes, which node will not have any children? Okay, have you done this? Which is the root node? A. Okay. I will draw along with you. Okay. Okay. Just 1 minute. Yes. What is the first node? A. So A becomes the root node. Next, B and C. Where they have to be? Can I draw B on the left and C on the right? Okay, D. What is the position of D? What is the position of D? Okay, left of B. What will be right of B? Null. Correct. So right of B will be null. Then E goes in left, F in the right, G and H will become left and right respectively of D. This is the resulting tree for the given set of elements. Yes or no? Okay. Now the next question. If the new element to be inserted is I, new element to be inserted is I, and the direction given is right, right, right. Direction given is right, right, and right. Is it valid? Check it and tell. Is it valid? Yes. If I give, and where I will be inserted if it is valid? Right of F, correct. If the direction, now, if the new element to be inserted is I, and if the direction given is right, left, right, is it valid? If valid, where it comes? Right, left, right. It's valid. Yes, then it comes at right of E. Now if I give the new element to be inserted is I, and the direction given is left, right, right. Right. Is it valid? Not valid. Okay. Then I'll take that you have understood this. Okay. Just 2 or 3 minutes. I'll continue for this and then I'll be ending the session. Okay. Next thing is for this given binary tree, I can have the displaying of the contents of the binary tree in 3 ways. Okay. Okay, in 3 different ways. You can have the display of the elements contained in the binary tree in 3 different ways. One is called the in order, the second called the pre-order, third is called the post-order. Okay, I'll repeat again. In order, pre-order and post-order. What is the meaning of in order, pre-order and post-order? It is similar to the infix, prefix and postfix. Infix talks about in between the two operands, operator has to be there. In between the two operands, operator has to be there. Here, in between the two subtrees, the root node is there. In order indicates what? In between the two subtrees, the root node is there. So, I will write something like this. If I want to write in order is left tree, root and right subtree. Okay, every time whenever you want to print something like this in the in order fashion, then I will print it in the manner left, root and right. Left, root and right. So if I start for this particular tree, if I want to display the content of the tree, elements of the tree in the in order fashion, how the things will go on? Just pay attention. It will start from the root. Is it left? No. It goes to the left. B is left. D is left. Leftmost I have to start. I have to start from the leftmost. Who is available at the leftmost of the whole tree? Leftmost tree, node of the tree you have to consider. Which is the leftmost? G is the leftmost. So starts from G, then to its root. Who is the root node? D. So which is first to be displayed? G is the first to be displayed. Then who is getting displayed? D is the next to be displayed. Then right goes to the right. What is right of D? H. Okay, so this whole thing is a subtree. Now this subtree is nothing but left of B. Okay, so left subtree of B is done. Before going to the right subtree, you know that left, root and right. Okay, so who is the root of this left subtree? B. So B has to be visited next. Then left subtree, root, right is left out. Right is left out. So you just leave it. Now this whole thing, including this whole thing becomes the left subtree of A. Left subtree is done. Now where I am going? To the root. So A. Next, I'll come to the right subtree. In the right subtree, I will again recursively apply left, root, right. Okay. If I go to C, C has a left child. So I have to go to the left. Okay. So who is the next person to be visited? E. Then left is done. Then go to root. C is the root. Then go to right. This is the in order traversal for the tree. I will take one more example for you. Okay, if you are not convinced with this, I'll take one more example. Okay. Now, you just imagine like this. I have a tree like this. Say 10, 40. The elements inserted are like this. 50. Then I have 60. Then there is 5. Okay. Then there is 55. If suppose this is the tree that is given. If I ask you to write the in order traversal of this tree, how do you go ahead? It goes like this: left, root and right. Okay, left, root and right. So if I start for this applying left, root, right for the whole tree, how the things will go on? Always you have to start from the leftmost node of the tree. Which is the leftmost node of the tree? Can anybody quickly comment? Which is the leftmost? 60. 60 is the leftmost node of the tree. So that is the first element to be visited. Okay, 60 is the first ever element. Then this becomes the left subtree of node 40. Of node 40. Okay, so left is done. Before going to right, I have to visit 40. So next element in the in order is 40. I have done left, I am done root. Now I have to go to the right part. Right, suppose at the right side, if I have 3 and 4. Now tell me how the things will go on. Which is the next element to be visited? Can anybody tell me quickly? After 40, which is the next element to be visited? Is it 5? Is it 3 or 4? It's 3, correct. You have to go to the leftmost part of that subtree. Again, the leftmost part of this subtree is 3. Okay, so 3 comes, then the root is 5, then the right. So I'm done with left subtree, I'm done with right subtree as well as the root. This whole thing is nothing but what? The left subtree of 10. Okay, left is done. Now write the root. Which is the root? 10. Then go to the right side. On the right side, 50 is there. This is a root node. So root node whenever is there, you have to search for the left subtree and the right subtree. Is there any left subtree for 50? No. So I can very well write, left is absent, so I can very well write the root. Then I'll go to the right. So this is the equivalent in order traversal for the given tree. Okay. Today's homework for you. Okay. For the given set of elements that I am dictating right now, you are supposed to construct a binary tree and write the equivalent in order traversal. Quickly take down and we will end the class. Take down quickly. Elements of the array are as follows. 52, I'll repeat, 52, 28, 35, 10, 11, 23, 23, null, 17, 17. Okay. You have to construct the binary tree for this, then write the equivalent in order traversal. Tomorrow's class, I'll be covering pre-order and post-order. Then I'll be going through the implementation of that, then the binary search tree. Okay. Somebody has commented. Let me just check. Upload 23rd December recording. Okay, circular link list. I'll do that, Nandita. Okay. Yeah. Yes. Anything else, or shall we end the class for now? Shall we end the class? Say yes or no, man. If you ask me to take the class, I'll take the whole day class. Okay. But there has to be a full point for the class. Let me know from your end. Okay, thank you all.